Well, a good morning to everyone that has just joined us, and hello if you're watching the replay on this. Welcome to the first of our 2022 online learning webinars. This time it's all about understanding sprayed foam insulation in domestic roofs. I'm your host, Andy Ferguson, and today joining me, I'm pleased to welcome Steve Hodgson, CEO of the Property Care Association. We are about to start the main presentation. For those that have just joined us, if you do want to ask a question over the course of the webinar, if I could point you to the chat, which should be running down the left or the right-hand side, or if you are on a mobile device, just simply pull it up and you should see it there. Alternatively, if you do want to pose a question via email, you can just email it to me at andy@property-care.org. So it is that time now to start the main event. So, Steve, spray foam insulation in roofs. What exactly are the implications? What do we need to know when we're expecting roofs with sprayed foam insulation applied to? And what key considerations do property and construction professionals need to take into account? I know that's a minefield of information, but I'm hoping you can give us some clarity towards certainly some of those points.
Okay, well, thank you, Andy. Well, let's crack on because time's short. There's a lot to cover. So I'm going to approach this kind of in a relatively logical way. I think I'm going to start with a description of why the PCA are in this particular conversation, why we've taken an interest in it, and how we came to be in a position where we've issued guidance to members and why we've done that. I'll cover out some of the issues, the bigger issues in relation to inspecting buildings with PU foam, and pose a few more questions, because not all there aren't answers to everything as yet. There's certainly still opportunities for further learning and for the improvement of delivery of these products if that's what people want. So we'll start really with an introduction to me. That's me. Steve Hodgson. I do not manage Manchester City, though I wish I would. Pays better. It's probably less stressful too. But that's the association. Most of you know us. We are primarily there to serve the interests of our members. But we are interested in providing assurance to customers and consumer protection. We are an organisation that attempts to drive standards, and over the last few years we've been very interested in not just promoting best practice, but promoting discovery and learning and research for research's sake. Research for commercial sake and for better product delivery. One of the things that drives me is an interest in buildings and how buildings fail. So why did we start work on PU foam? So we became very much aware of the mood amongst members and amongst the surveyor community, where we had a situation where lenders' policy on the policy that lenders adopt with regards to lending on properties with foams was all over the place, and still kind of isn't totally unified. So there was that element. We found ourselves with questions being asked, and we weren't in a position to answer the questions that were being posed to us sensibly. Then at the same sort of time, this was back in the summer of 21, Alan Milstein from the Residential Property Surveyors Association approached me. I know Alan a little bit, and Alan, I know him quite well now, approached us and sort of asked us about this, knowing that we were very interested in timber decay and the methods of rot and that sort of stuff. And so, I was hooked. We were interested. We saw the need and the value in that. So I looked at this initially and wrote an opinion piece back in June. It wasn't totally well informed, but it discussed some of the issues around the mechanisms that we could consider and perceive for modes of decay and modes of failure. And yeah, it wasn't perfect by any means. It generated a bit of interest and some well-deserved criticism. Still up there if you want to have a look at it. But things have moved on a great deal since then. But the fact is that off the back of that, there was momentum to then start really thinking about how we move things forward. So what did we want to do? Our PSA and PCA sort of got their heads together and thought, right, we need to consider the problem fully. We need to evaluate the existing knowledge. We need to explore the need for further research and where possible, then develop guidance. And the motivation for this was to develop guidance for our own audiences. So our PSA obviously have their residential property surveyors community, and we were particularly interested in simply providing information to our own members that were dealing with building preservation and meeting foams and not really knowing how to manage them. So off the back of that, our PSA and PCA sent out some invitations, and we were actually quite surprised by the rapidity and the breadth of the audience that we were talking to in the first round of invitations. And so we had representation on the wider group from mortgage lenders, from polyurethane foam producers, from surveyor groups, and RICS joined the RPSA in that group. We had heritage organisations. I think we had Historic England, Historic Scotland, and CADA were involved. We had academics from a number of universities, including Bangor University, that have a specialty in timber decay and durability, timber durability. We had a couple of consumer protection organisations, and even a journalist, a specialist construction journalist, was interested to join. So we met and we looked at the issues. Now, some of the illustrations in the background are there just for interest and keep your eyes busy. But these are the sorts of things that kind of make us scratch our heads. We see a slate roof there in the background in the inset, and then we see what appears to be open cell foam sprayed directly over the top of it as a before and after. Now, bear those in mind. We'll pick those up as we work through the presentation, and perhaps you'll see some of the confusion that starts to come in when we're looking at this. So the issues. The first thing we discovered was that surveyors don't know and can't often know what they're looking at when they go into a roof. And actually, the more we think about this, the less that we know that can be expected to know what they're looking at when they go into a roof. X-ray eyes would be a great thing for the average surveyor, but as yet I can't buy them from Lascar. There was a lack of accessible, unfettered information, unrefuted information and guidance. There was also some concern among surveyors about the protection of their PI liabilities, of course, and we're in a terrible situation with PI at the moment. So everybody should be protecting their PI. There is a growing public concern over PU foams. Again, we mentioned the inconsistency in lender policy. There also seemed to be some anecdotal evidence that was a lack of accountability from installers. Now, I'm going to separate installation contractors from manufacturers and suppliers. Manufacturers and suppliers, to a man, are large, serious companies. You don't brew up PU foam in a barrel in your back garden. It's not something that you can do without the infrastructure and the know-how. So the manufacturers generally almost totally are what I consider big, grown-up, proper companies. The installation quarter is less well regulated, and that's where I'm saying about the kind of the suboptimal workmanship, the suboptimal specification, and the accountability of installers was not always there. There was also no mechanism for feedback loops, so concerns raised in one area could not necessarily be fed back easily to people that could affect change, and so that was something we wanted to change too. The other thing that came up as an issue, and it may seem slightly out of pace on this list, but PU foam is not scored or calculated when you're working out your EPCs. So that in itself is kind of a bit of an anomaly if you're putting insulation into a roof. So we did our homework, and trust me, I have read gazillions of sheets of paper looking at product registrations. I've got stacks of it set on my desk now. international and national research papers. We spoke to surveyors and got lots of anecdotal accounts of what they had seen, both good and bad. And there were some accounts where surveyors came to us and say, well, we have never seen a problem. We've seen lots of spray foam, but we haven't found a problem. On the flip side of that, we also had lots of surveyors that came to us, or good number of surveyors that came to us and said they've seen lots of problems. And some of the photographs that you'll see as you work through this are some testament to some of the problems that those surveyors brought to us. We also met very openly and in good spirits with some of the polyurethane foam manufacturers, and learned, I have to say, a great deal. So what do we know? So the foams differ in consistency, they differ in density, but essentially at their heart, they're polyurethane. A polyurethane is a product that is ubiquitous. It's everywhere. It's not something that was invented, as all of us know, I'm sure, for squirting into roof voids. It has enormous numbers of applications. The chances are that the majority of us have sat on something that's probably got polyurethane in it right now, or we're holding a steering wheel in a car that's got polyurethane in the steering wheel. But polyurethane has this capacity where if you mix it correctly and you do the right things and you react it in the right way, you can turn it into something that can be sprayed. So the foams can vary enormously in vapor permeability and waterproofness. According to product registrations, product approval sheets from Kiwa and BBA, they can be anything from 3.3 mu to 38 mu at 70 mil. 70 mil is important because the density is a mu is a relative vapor permeability when it's set against that of air. So it's how easy vapor can move through something. So the depth is important. And 3.3 is 3.3 times more difficult to get through that material than it would be for vapor to move through air. So you can see the difference between 3.3 times as difficult to move to 38 times more difficult to move is quite considerable. So I know this sounds very straightforward, but foams are described as either being open cell or closed cell in structure. And this is something that will kind of now take over a lot of the presentation. We're talking about open and closed cell, but there is no absolute situation where one is completely open and one is completely closed. Even the closed cell products will have some vapor permeability, and some of the very open cell materials will have some vapor resistance. However, at 3.3, it's very vapor permeable. At 38, foams described in some of the Kiwa and BBA certificates are described in that documentation as having high water vapor resistance. So, you know, let's kind of make it simple and say open cell vapor permeable, closed cell pretty much vapor closed. So let's look at closed cell foam. Closed cell foams came on the market in the UK some decades ago. I haven't been a surveyor, a grunt surveyor doing bulk inspections for a very long time, but I remember in probably the mid-90s that we were starting to see terraced houses in Leeds and Bradford, Halifax and Huddersfield that were starting to be hit with sprayed foam, and that was used specifically for gluing the roof together. So if the roof was failing, coming to the end of its useful life, slates were slipping, defects were becoming apparent, it was being sold to homeowners as a method of prolonging the useful life of the roof. You didn't have to worry again. You squirted this stuff on it, it'd be fine. It'd glue the roof together. You get rid of the whole issue of nail fatigue. You'd rescue the roof. It's often relatively thinly applied. It's there primarily as a bonding agent rather than an insulative agent. And so it's important that if you're using it as a bonding agent, you preserve the ventilation in the roof, because you're still trying to get air to into the void, so you retain a cold roof space. I've used the term sticks like snot to a blanket. It absolutely does. The people that proofread my slide deck said that I shouldn't use it, but I know what I mean, and I'm sure you know what it means. It's really, really difficult to move. It's permanent. It's very difficult to shift. As I say, roof ventilation is preserved. You maintain a cold roof. So what are the problems with closed cell foams? Now, some of this is opinion, some of this is fact, but in my view, using a glue to hold together a failing roof from the inside, knowing that actually, the roof is liable to water ingress, was never really a very good idea. Roofs break, roofs suffer mechanical damage, they suffer wind damage, they fail. And so putting this watertight impervious material on the inside of a roof to glue it together was just odd. It fails. The slates and the tiles and the stonework that you apply it to become unusable and unsalvageable. The roof, if roof ventilation is compromised, or if it wasn't very good at all in the first place, then there is an increased risk of condensation. So the whole kind of dynamic of the roof with closed cell foam applied directly to the backside of slates or tiles as an adhesive is just not cool. You can see the bullet points. All of those things are, I believe, accurate. Here's a photograph of what I believe to be closed cell foam applied to the backside of a pretty old roof, directed to the slates. You might notice, and this isn't my photograph, and I will say some thanks to the guys that helped me with photographs at the end of the presentation. But in this roof, part of the roof appears to have already been stripped and recovered, and membranes put on. There is some speculation that could potentially have been because of the accelerated rate of failure of the roof because of the foam. So, consequences. Difficult to extract as if difficult to encase timbers. Well, of course it is. You can't see what you're looking at. The fact is that if you have to undertake or effect a repair on the roof, you can't, because you can't get the slates up. You can't actually tack in you can't put a lead tag on a slate. So really you've got a problem both ways. You can't fix it. You actually can't even see the leaks very quickly. Any historically important roof coverings are pretty much destroyed by the foam. You really can't get it off sensibly or economically. And as far as we're concerned, and I think it's the correct advice, that if our members discover roofs where you've got bonded closed cell insulation applied directly to the roof coverings, then we would always, or I would always suggest to my members that they advise any pre-purchase clients or any homeowners that early roof renewal is probably something they should be budgeting for. So let's look at open cell foam. Used as an insulative material to promote thermal gains, reduce heat loss. It has very little by way of adhesive capacity. In an ideal situation, and there are some variations in the product approvals, but this again is my view on how it should be done safely. It should be applied not to the roof coverings, but it should be applied to the vapor permeable underlay. And vapor permeable underlay, there's a really good reason for that, and we'll kind of discover that and talk about that as we go. It's usually applied to 70 to 100 mil thickness. The roof ventilation is not preserved. It runs completely counter to the whole idea of energy saving. Is if you apply an insulative material, an energy saving material to the pitches of the roof, then to vent the void. So what you do is you change the void from being a cold void into a warm void. So any ventilation inside the roof space should be eliminated by the foam. The one thing that I wish I had some samples on my desk now, but surveyors often ask, how do you tell the difference? There's if you come across open cell foam, if you take your surveying screwdriver, a pen, or your finger, you can generally push it into the material relatively easily. With closed cell foam, you can't. The open cell foam, the stuff that has a very highly vapor permeable structure, breaks up relatively easy. It's fragile. It allows vapor to pass through it relatively easily. And this is why vapor permeable underlays, in my view, are so important as the medium to apply it to, if you're going to apply it at all. So there's a picture of a bit of open cell foam, nice and fluffy, stuck right down into the wall plates, right down into the gaps. So it's eliminating both transfer of heat from the air through the underlay into the slates and to the outside, but it's also getting rid of not just that heat that goes through the solid structures, but it's also going to block up all the gaps and cracks. And you can see on this photograph how well that foam is stuck to the rafters and the wall plate, and it's creating that warm environment. So insulation properties, bore adhesive characteristics. Product is not waterproof, but it will retain some water against the timber if the roof leaks. So you need to be very mindful of that. It's relatively easily damaged, but from inside. It's also very easily damaged if somebody comes along to change a slate or to put a vent pipe in, or anything else that may go on in the roof. Very, very fragile. Converts a warm roof into a cold roof, and the interstitial condensation risk, I believe, is massively increased if the material is applied directly to the slates or the stones, stones, tiles, or it's applied to a bituminous underfelt or a plastic underfelt that isn't vapor permeable. And we'll kind of explore that a little bit more as we go. Just to also set up, just to give you some information about what the product data approvals say should happen before installation. Most product approvals, actually, when they're talking about roof voids and apexes, is you talk about they talk about the use of a hydrothermal model before installation. That's done to understand that actually you're not going to put the roof void, which will now becomes a warm roof void, into moisture stress and causes an overloading and overburdening of the roof. Now, the hydrothermal modeling is relatively straightforward. Unfortunately, however, in some of the most of the properties that I've had any dealings with at all, none of the, and we've had a fair few calls over the last couple of weeks, nobody that I've spoken to in regards to the homeowners know anything about the results of a hydrothermal model or any preambles to the installation. They don't have that paperwork at the moment, which is problematic. You also perhaps have to think about what's going on in the occupied space below the property, because that's where the moisture that's generated that's going to go into the roof comes from. Some of the products, and we're talking about open cell foams, require application to vapor permeable underlays. Some, on the other hand, don't. There is also some installers who claim that it's okay to apply open cell foam rather, directly to the underside of slates and tiles. I think that's nuts myself, but there are practitioners that will approve that or say it's okay to do it. So the good news, and there is some good news. I was very skeptical, but I've come to the realization, and I think it's a fair realization, that if a contractor or an installer undertakes the correct hydrothermal models, understands what's going on, understands the condition of the roof, understands the vapor permeability of the underlays, does all the work correctly, and then applies the foam as per the product approvals in a normal situation, then actually it can be pretty safe, and there's probably little risk of condensation damage or anything else. There's always a theoretical risk about, you know, water retention from a water leak, but generally, actually, they can be pretty good. They can work, and they will return very good results with regards to thermal performance. So now for some of the not so good news. If open cell foam is applied to an impervious underlay, dew point can occur on that material. Now, I'm not saying that dew point won't occur even if you've got a highly permeable membrane that it's applied to, but the difference is that when the solar gain sort of comes and hits the roof coverings, that will be burnt off and it will convert to a vapor, and the roof will dry out, and the water will be vented to the outside. If dew point occurs and it's not a vapor permeable membrane and the roof heats up, then unfortunately what can happen, and what we've seen evidence of, is that the water hangs around. It can't go anywhere. It can't boil off, can't burn off into the atmosphere, and it builds up across the top of the rafters, and it causes premature decay. I believe that if you apply open cell foam directly to slates and tiles, then exactly the same mechanism takes place. You've got essentially a vapor resisting layer, which is the back of a slate, and you can get the same problems. We've also seen issues, and there's some of these photographs are from installations where this has happened, where foam has been applied directly to the underside of permeable tiles. The water comes through the tiles because they are capillary open, and rather again than that moisture being cycled back out when the place gets warm, it gets into the top of the rafters, causes a problem, and the roof fails. The other thing that's a reality with the presence of foam is that roof leaks, when they do occur, and they will occur, if you've got a roof and it rains, at some point it will leak. That's just inevitable. But roof leaks may be slower and more complex, slower to spot, because some of the water is retained for a while, even in open cell foam. And then when you do come to do what should be a minor repair, they can be much more complicated to facilitate because of the presence of the foams. So some other considerations when you see PU foams. This photograph, I was looking for a photograph with a PIV unit in, and I didn't think I had one, and I realized in my library of shots, here indeed was one lurking in the background. But there are a number of things that you should consider when you're looking at a roof with PU foam. It shouldn't come into contact with chimneys and flues and anything hot. There is also a question about contact with PU foams and cables. And cables and conduits. So PVC and some PU foams don't get on very well, and there's been quite a number of reports and some pushback to me over the last few days about issues with rapidly decaying insulation coatings where they've been embedded in PU foam. I also am lucky enough to have some good contacts in the ventilation sector. Of course, we have a number of members that are particularly focused on ventilation provision and manufacture of units. And also, you know, the fact is that a positive ventilation system that's installed in a roof relies on a bit of solar gain to warm the air that it's pumping into the rooms below, but it also needs infiltrating air. And if it doesn't have infiltrating air, it can't function. The only thing that it can do is draw the air out of the building below and recycle it straight back into the property. So you can't put a PIV unit into a warm roof. So that's something that appears to be getting overlooked regularly as well. So those three things. Now, if you look carefully again at a lot of the photographs that I'm showing, you will see inadvertently that even on this photograph in the background, you'll see that there's cables embedded in the foam and that have been sprayed over. Even if there isn't a reaction between the cables and the foam materials at the point of application, it just makes servicing this stuff and getting to it and all the inherent issues that bit more difficult. So why are we bothered? And is it only decay that we're worried about? Well, in its normal, I say, in a good, dry, desiccant state, timber lasts forever. It doesn't fail. It doesn't rot if it's kept dry. Insects don't like to eat it if it's totally dry. Now, in most conditions, in most houses, at most times, moisture will have be in balance with its atmosphere, and the atmosphere is relatively conducive, and therefore the timber has a long expected life expectancy. It's all cool. What we're looking at, however, is relatively modest amounts of moisture in timber and in the atmosphere to tip timber over its thresholds and put it at risk. And so even in a normal situation where you take a cold roof, which has relatively low amounts of water in the roof, yes, from time to time the relative humidity may go quite high because it's relatively cold and you've got moisture generation in the rooms below, but it vents out. And also it benefits greatly from fluctuations in temperature with solar gain. Even in the winter, roofs can be very, very cold at night, but actually as soon as the sun hits them, they can warm up quite quickly. So timbers don't get a chance to get wet and stay wet unless there's a roof leak and unless there's some other defect. But the fact is that generally timbers are okay. Now we know, anybody that's spent any time looking at these things, that occasionally we find decay and we find insect attack, because there's kind of situations where the moisture contents are such that they can cause those issues. So we know we've got timbers that are susceptible to moisture because they rot. They rot in just general conditions. Now, if we change those conditions by removing ventilation, by messing about with the balance, then there may not be a situation where you've got raging dry rot, but actually it pushes it into a situation where insects can become, can sustain themselves. And so this is one of the kind of the more long-term issues, that even where we've got PU foam performing pretty well and there's no obvious calamitous defects, the issue of changing the moisture conditions in roofs hasn't been looked at to any great degree for any great length of time. And so one of the things that I'm concerned about is not so much calamitous outbreaks of decay, but is actually an increase in the prevalence of wood destroying insects, common furniture beetle, woodworm, of course. The trouble then is that how do you spot it? And even more of a challenge is if you've got foam in the roof, how do you treat that common furniture beetle? How do you treat the woodworm in a comprehensive and sensible way? So now I've got a bit of history with this now, because it appears that if I type spray foam insulation into Google, all my social media channels fill up with adverts for spray foam insulation. And these are just some of the examples of stuff that has popped up on my social media feeds. Now, the photograph on the far left is another before and after. This is advertising from a contractor that shows a roof in terrible condition. So you've got ripped underlays and tiles, and the after photograph appears to be some sort of adhesive sprayed foam insulation. That's not sending out the right message to us as a surveyor community. That doesn't look right. And the roof on the right hand side, yes, it's talking to me about saving space and saving energy, but actually the roof was already insulated with material across the rafters. What actually have we gained? And I did zoom in on this photograph, and actually if you look very, very carefully, and it's probably difficult to see it if you get the same advert pop up on your social media feeds, the gaps between the rafters and the foam are quite quite significant, and you wonder about continuity. So even in the adverts that are being put out by quite keen installers, even looking at the adverts, there's reasons to kind of scratch your head and wonder why. So one of the things that, going back to where we started, was this need and this thought that we might need to do further research. I don't think for a second that there is going to be any slowdown in the use of foams and novel materials in construction. And I really don't want to stand in the way of progress if these things can deliver results that help help halt global warming, help reduce fossil fuel use, save money on people's energy bills. But I do think that there is a great deal more work that needs to be done to really understand the implications of a lots of these new technologies with retrofit. Certainly with the use of polyurethane foams in roof voids and in underfloor voids, I remain concerned that we haven't got to where we need to get yet with the amount of information that is available. Subfloor voids, there's a picture of Qbot there. They're making great strides to try and provide solutions for putting PU in subfloor voids. We know there's work being done by UCL to try and look at what happens when this stuff is put around joist ends and timber structures that may be in moisture balance without the foam, but what happens when the foam goes in around a joist pocket that's kind of a bit marginal. We had thought when we first looked at this that perhaps the wider working group, PCA, RPSA, may well find some money to do some research on this. I think towards the end of our initial meetings, we decided that probably wouldn't be something that we would do, and that actually any research probably should be sponsored and pushed forward by the people that were likely to profit most from it, rather than from the organisations that were trying to understand it from a survey diagnosis point of view. I also think that having looked at this with some detail and read an awful lot about it and spoken to an awful lot of people, that the cautious approach in respect to building diagnostics and inspections is the right one to take. The fundamental problem with looking at a roof where sprayed foam exists is you cannot see the structure. You can't see the valley boards. You can't see the purlin ends on occasion. You can't see the wall plates. All areas where historically we would spend some time scratching around and trying to look at and trying to get to. So we can't see that. The other issue, of course, is that we know that with all measures with retrofit, the conditions of the occupied space below the roof or below the retrofit is really important. And there is little being done. And I know one company are seriously looking at this. One of the manufacturers of polyurethane products are seriously looking at this, is the impact on the occupied space from putting PU in the roof, creating a warm roof space. Does that increase the moisture stress in the occupied spaces below? And it is important, in my view, that actually an assessment is made on the ventilation characteristics of the occupied space as part of the kind of the specification or the consideration of sprayed foam in the roof. So let's talk about some of the actions that have come out of the work that we've done. We're delighted that there were two position statements that were created that everybody agreed on, and there's a link to them there. One relates to the use of any foams in listed buildings or buildings that are protected by legislation, and it was agreed that the use of PU foams in listed buildings is something that it requires listed building consent. And so we've put a note out that kind of unifies everybody on that particular issue. We're also of the view, and I think everybody agrees, that we shouldn't be applying PU foams to roof materials that are architecturally or historically or culturally important, like grey slates from Yorkshire or Welsh blue slates or this sort of stuff, because it does destroy them, and these things can be reused and should be reused if at all possible. So those two position statements. PCA I would say our mission was kind of vaguely accomplished, because we put together an information paper directed at our members that kind of covered most of what we've talked about today and gave some instruction on inspection process. And so, what we've said in that guidance to our members is that you have to understand the moisture content of timbers. You need to be able to understand the detailed construction of the roof, and that includes, which is often a difficult thing, the vapor permeability characteristics of underlays. Very difficult to do retrospectively, but you really need to establish that. The construction of the foam used, open or closed cell densities, that sort of stuff. The condition of the roof coverings, obviously important. The vapor permeabilities of the ceilings as well, which again is not easy to establish. And believe me, I was on the BS 5250 group that talked about this for weeks and weeks and weeks. So it's not necessarily that easy to do the calculations to understand ceiling ventilation. And we also are very, very conscious of the need to think about air management inside the occupied spaces. Now, as well as ourselves, Residential Property Surveyors Association, our PSA, have provided some guidance for their own members. There's a quote there from the document. That's a free to access document as well. And I know that RICS have also put up a page recently, an article recently on sprayed foam insulations. So there are lots of things that have come out as a result of this group. So what next? We're pretty sure that there's lots to learn about PU foams yet. As an insulator and as a construction product, because it's being used currently within walls as well, not only as an insulator, but also it's being cited as a product that can be used for flood protection. So that's another point of contact for us as well. But PU foams and these sorts of materials are not going to go away, nor should they. But we need to understand more about them. We know that studies are being undertaken about suspended floors. We're very interested to see the results of that coming out of University College London at some point in the future. We also believe that the polyurethane foam industry has a real job to do. I honestly believe that there is a chance for the PU foam to move forward and do really good stuff. But the industry has probably quite a significant legacy of stuff that they'd rather not have. Properties where work has been done suboptimally, and where PU foam has been used as a bonding agent to prolong roofs for commercial reasons, but actually those are failing and causing significant problems now. And so I think before PU foams can be embraced, I think that there has to be some regulatory framework and some consumer protection around the industry, and perhaps that's something that is a take-home message for the PU guys on the call today. And they know that I've discussed this with them in the past. By industry estimates, and I don't know how accurate this is, but there are about 250,000 houses with PU in their roofs right now. Some of them were great, some of them won't be. But until that framework, until that assurance that actually every installation is done according to the best practice and is done following the requirements of the product approvals, then I'm afraid that I feel that legacy of questionable installations and design extends. But what I would say, just as a sort of a sign off, is that PU foam is not by any means the only challenge for domestic surveyors moving into a world of retrofit and energy saving. I honestly believe that this is a subject that we're only just scratching the surface of the complications and the challenges that will come from trying to understand buildings that have been retrofitted either with internal, external, or cavity wall insulation, whether it's in the roof or under the floor. We are changing buildings in a way that has not been known since we decided to put chimneys into thatched buildings for the first time. And we're really really don't quite know what we're doing with some of the work that we're doing, and certainly some of the detailing on the work that we're seeing done at scale scares us a little bit. So anyway, I think that kind of wraps things up. I thank you all for taking the time this morning to listen. I hope there's some things that you've learned. I hope that there's probably some things that you've kind of built existing knowledge on. I hope you've kind of gained some confidence in some respects that PU is not always absolutely terrible, but it always requires a good level of investigation and understanding before you put your PI liability on the line. Now, there's just before I finish, the photographs were not all taken by me. I'm very grateful to the Surveyor Hub community who have allowed me to strip some photographs from some contributors. Adrian Cartwright, Michael Newport, Ross Charters and Oscar Cayenne has also let me have some images. So I'm very grateful to them. I'm also, as I say, very grateful to the community that is the Surveyors Hub for seeing it right and letting me have some of those photographs. So I think we've got a few minutes for questions. I'm sure there will be some. So please fire away.
Yes, no, there certainly is, Steve. Firstly, here, many thanks for taking us through that presentation. I especially quite liked that, just reiterating just what you said there at the end, which is balancing the fact that it's not just all about bad news. We're not here to kick people down within the spray foam and the PU industry. It can be good, as you quite rightly pointed out. If it is applied properly, correctly, all the best practices are followed, it can be pretty safe. The only problem, I suppose, that we are seeing from our perspective is there just seems to be a run of where we're seeing some bad associated with it. But if I quickly move on to questions, because as you quite rightly said there, we do have quite a lot of questions in. Folks, I will say this, I don't think I'm going to manage to get through all the questions, but we will try our best. And if we don't, I'll pass the questions over to Steve. And if he can answer them, maybe via email, I'm sure he'll try. But Steve, starting off right from the top, it's been a question that's actually been posed by several people. You touched on it during the presentation, but question being is, how do we establish whether it's open or closed cell foam? Now, there was a follow-up question.
Okay, let me deal with that really quickly.
Okay.
Stick your finger in it.
Okay.
And if you're not comfortable sticking your finger in it, stick a screwdriver in it, because the finger will make a big hole. If it's open cell, lightweight open cell foam using an insulator, it's actually really easy to push a screwdriver or a spike or whatever through it. It goes through with relatively little resistance. Closed cell foam using adhesive, it will resist that. It really is. And if you don't know now, by the time you've looked at 3 buildings, 2 with one sort and 1 with the other, you will know the difference. I will get some samples, and if we kind of start wandering around, I'll make sure they're in my car, or if anybody meets me, and I'll be able to show you. I wanted to have some today because it's very easy to sort of say squidge, it goes in, and then bounce, it doesn't. It really is quite simple once you get your eye in.
Yeah. Well, I mean, Jason Burns actually came up with an interesting comment. I don't know if this occurs within the PU industry. You might be able to tell us, Steve. If not, maybe someone on the chat might be able to tell us. But he was suggesting, could we colour code foam types for easier identification for general surveyors, similar to gas membranes? Do you know if that exists?
No, I don't. It's not my area of concern. The question is, what I would say is why is it important? At the end of the day, if you find a dense foam and it's applied as an adhesive thinly to a roof and directly to the tiles, it probably shouldn't be there. If you find an open cell foam or a softer foam applied directly to the tiles, it's probably problematic. The fact is that the nature and the density of the foam is less important than the underlying condition of the roof and the risk phases that that foam poses. So being able to identify hard and soft is probably important, but it's less important than understanding the implications of the presence of the foam in the first place, and then adopting good inspection protocols to understand what's going on, what the risk phases are, where the areas of decay may be, and what to do with it if you find problems. Now, as I say, I kind of keep coming back to this on these conversations that I'm having about. Our motivation on this was and remains the provision of reasonable quality information that helps to guide my own members of the PCA, and that's where I am, and that's where I'm going to stay. If others want to derive some benefit from that, that's great. One of the things that you may have noticed on the RPSA guidance was that they suggested that on that quote, that you may want to recommend further investigation. The issue is that who's going to do that further investigation? I'm not sure even really that my members want that as an investigative task as a standalone, because they have to carry the PI liability for what they can and can't see with those installations. But it doesn't seem fair just to sort of leave homeowners in the lurch and say, well, there is no way of investigating. We have to find a way of doing those investigations. But I'm not quite sure who those people that are going to be doing that further investigation are at the present time. I want to equip my members to do it, but I'm not suggesting to them that they should, if you know what I mean.
Okay, all right. Well, just a quick comment that Leslie Milson just made on the chat there, and it was to do with the previous question. She's suggesting that if you're not comfortable putting a screwdriver or your finger into it, you can tap it to see if it sounds hollow or not. Would you agree, Steve?
No.
No? Okay.
Not necessarily, because it depends what it's applied to. If there's a void behind the foam, then it might sound hollow. Yes, there is. I'm sure that there is an element of kind of understanding density there. And yeah, if you've got your ear in, then you might be able to do that if you've got some experience. But I think that might be slightly risky. I don't see any reason why you can't, use. Every surveyor has a screwdriver, and if you haven't, go and get a coat hanger and just prod it. You won't. Give it a poke. That's for me. That's the way to do it. Tapping. I can't tell you what level of noise you expect, but they all sound a bit hollow to me when you tap them.
Okay. Well, moving on. Next question from Adrian Hull. This is regarding open cell insulation in a warm roof application. He's asking, what about the timbers? Aren't they acting as repeating thermal bridges?
Timber's a wonderful material in that it's a great insulant. So actually, what you're doing is you're using that insulative capacity of the timber. The trouble with that is that you will, and you can potentially get a gradient of insulation and therefore temperature through the thickness of that rafter, if you like, or at the interface between the foam and the rafter, and that will have an effect on the water activity and the RH at different points along that piece of wood as it goes deeper into the insulation. And with open cell foam, it's not the cold bridge that I'd be worried about. It's the fact that actually the deeper you get into the insulation, the colder the bit of wood gets, and therefore if there's lots of moisture about, the higher the RH and the higher the water activity on that piece of timber. And even if that doesn't cause a problem with decay immediately, and it can, or it could potentially, you're increasing the moisture contents to a point where bugs may well decide that that's a good place to be. And so actually you can potentially accelerate or introduce conditions that might be favorable to wood destroy insects. But the thermal bridge issue is something that I wouldn't be massively concerned about, because timber's a great insulator.
Right, okay. Perfect. Well, just staying on the subject of potential problems, Jack Waterman's asking, would the provision of a vapor control layer under the spray foam mitigate issues with interstitial condensation?
Yes. Good point. Very good point. The fact is that if you look at the keyword BBA certificates, where you're using foam to create room in roof, or you're looking at the NHBC guidance on creating rooms in roof where you're putting a ceiling up, they require a vapor check. They say that you put you spray the foam into the void, you put a vapor check up on the warm side, and then you put your boards up. That's really the whole issue. You know, we have been around the block for a very long time. We don't put vapor checks on the cold side of insulation. We put vapor checks on the warm side of insulation. Now, the question for me, however, is if you're gonna install this foam retrospectively and then put a vapor check on the inside of the foam, surely there would have been a better way of doing it than having to go through all of that. But yes, to answer your question, you put you control the vapor in the warm space, and you don't let the vapor get to the cold bits. You're massively reducing the risk phases. In the same way as if you were to insulate your roof with putting normal rock wool in across the ceiling, we've seen situations where the roof goes into condensation very readily, and you get quite a lot of water kicking about. One way to eradicate that or reduce that, two ways to reduce that, is to reduce the amount of moisture burden coming from the occupied space through good ventilation. The other way is to put a vapor check across the ceilings, in between the ceiling and the rafters, and therefore you don't get the vapor transfer into the cold space. So good question, absolutely correct, picked up in some of the documentation that's kicking about, particularly if you're going to use it in occupied space, in occupied roofs. So yes, absolutely right.
Perfect. Well, here, folks, just to let you know, we are probably just running over a little bit. If you can stay with us, that would be great. Steve, I probably only I've got two questions that seems to be the case. Several people were asking both via email and via chat. I'm going to start off with the first one, which has been asked by several folks, which is to do with the spray foam in itself and getting rid of it. Is there any chemicals out there that can help dissolve it and get rid of it, or is it just sheer manual hacking off?
Don't know. Don't do it. It's not something that I've kind of even shown any interest in. Isn't its removal? That's for somebody else. As far as I've seen, the way that it's generally removed is manually. It's usually taken off as the roof is being changed. I have been around long enough to know that if you've got a material stuck to an underfelt, it's not easy to remove internally without damaging the felt. So I want to kind of claim. I don't want to make any claims that I understand the processes for removal, but as far as I know, it's manual. I don't know that there are any cases. You know, PU foams are pretty stable stuff. You know, that's one of the characteristics of polyurethanes that make them so usable, durable, and so useful. So I'm not aware of anything that we can use to dissolve them.
Well, folks, do you know, if there is anyone out there that does that is aware of anything, then feel free just to put it onto the chat. If that would let us know, let everyone know. But Steve,
what I would say is, Gervais has suggested that well, you can use acetone before it sets. Using acetone inside domestic roofs, Gervais might be a bit scary.
But you know, thanks Jarvis so far for contributing though. But Steve, last question. It's slightly off topic, but there now has been quite a lot of people asking similar theme. We've been speaking a lot about problems with dampness, condensation, rot, and etc. that potentially come off the back of spray foam. But what about the risk of fire? After Grenfell, have regulations kept up to date with things such as spray foam when applying it to it in roofs? Is there a risk in domestic houses?
Okay, well, I'm not a fire expert. I don't have any qualifications to speak on this. However, one of the things that all the approval certificates do is consider the fire risk. As far as I am aware, there are no increased risks from fire from PU foams, because they all are packed with fire retardants. So they will burn if they're set fire to, but they won't support a flame. They don't combust under their own under their own weight. They can't support their own combustion. So if the roof catches fire, my understanding is they will burn away, but they won't actually burn and support a flame themselves. So my understanding is that the manufacturers have looked at this and they've got solutions for the whole fire, the fire risk issue. It was one of the things right at the beginning of this that was thrown up as a question: was there an issue with increased fire risk? I have to say that I put that in my own research to bed quite early, because it appeared that was very well covered in the formulations that are used, and that those issues had been well served by the manufacturers. So fire risk, I again, qualify it, but I don't think there is a massive issue with fire with the current foams at all.
Okay. Well, folks, I do apologise if we haven't had a chance to answer your question. I will pass them over to Steve. I'm not going to make any promises if Steve can kind of get back to you, but if he can, then fabulous.
Listen, I am gonna struggle with email questions. I've got a very, very full calendar over the next 2 or 3 weeks. So I'll do my best, but really I can't make anybody any promises that I'll get back to them. But we will have more on this. Everything that we've produced is all open access. Everything that we will produce will be open access. There will be more if there is more to learn. We're committed to being able to provide useful information to members. And as I say, if anybody else takes any benefit from that, then that's fine.
Perfect. Well, folks, for those looking for any additional information just on this, on the PCA website, which you can access straight from our homepage if you go on to it, there is a landing page just all about sprayed foam and being applied within domestic roofs. You'll also be able to find the information paper that Steve referred to earlier on within his presentation within there, as well as all the cross-industry group position statements, and if you're a surveyor, what you may need to know at the point of an inspection if you are looking at roofs with sprayed foam. We also have the technical document library. The link is there, where you will be able to find codes of practices, technical documents and guidance documents covering pretty much a whole variety of subjects: dampness, ventilation, timber decay and structural. In addition, as well, our professional section of our website, there is further guidance there, but also you will be able to find both the replay of this webinar as well as our webinar library if you so want to kind of dive in and find out more. Just in case there's anyone there that wants to learn a little bit more, we do at the PCA have a retrofit installation masterclass, which I'm pleased to say is both now online and in the classroom. We actually ran our very first masterclass on this week, which proved to be very successful. It's perfect for identifying problems and understanding the implications of retrofit installation defects. If you do want to learn more, please do contact our training team. But we also do have other training courses associated with managing moisture risk within building, which is in conjunction with UKCMB, and our flagship surveying, timber and dampness in building course, both online and in the classroom. If you really want to find out more information, the link is there. Just go to property-care.org/training. Just before we go, our next webinar, off the back of the recent RICS release of its paper, Japanese Knotweed in Residential Property, and the updating of the PCA support paper to this Japanese knotweed guidance for valuers and surveyors. Our next webinar is all about looking at that guidance and asking the question, how does it change the way we assess risk when it comes to Japanese knotweed? We'll hope many of you join us on the 31st of March. You can, if you do want to join us, you can register just by going to property-care.org/webinars.
All right. Well, listen, I think it's probably time we wound it up now, Andy. We're losing our audience, and people need to go to work. So, listen, thanks for all the messages in the chat. It's been a pleasure, and I really do hope that we've produced something that interests guys and girls out there in the real world. So it's been great. I'm going to sign off. Andy, perhaps we ought to shuffle off now and leave these guys to their day.
Yeah, thank you everyone for joining us this morning, and hopefully we will see you in a future webinar. Have a good day, everyone.
Bye-bye. Bye-bye.